Our topic today is to find the domain, range, and vertical asymptotes on logarithmic function.
First example is y equals log x minus 1 by the base of 3.
So, we were going to find the domain on logarithmic function.
So you should copy x minus 1 and put greater than 0.
Transfer negative 1 to the right side, and negative 1 will be positive 1, so it will be x is greater than 1.
So the domain will be x of x is greater than 1.
Based on the rule, range will always be y of y equal to real numbers.
The vertical asymptote will be x is equal to 1, which came from the domain x is greater than 1. Here is another example. Y is equal to 3 log 6x minus 3 by the base of 3.
To find the domain, 6x minus 3 will have greater than 0.
Negative 3 will be transferred to the right side and it will become positive 3.
6x greater than 3 will be divided into 6, therefore 6 over 6 greater than 3 over 6, both 6 will be cancelled, therefore 3 divided by 6 is equal to 0.5, which is 0.5 is equal to 1 half. Therefore, the answer will be x equal to 1 half.
And the domain will be x of x is greater than 1 half. So the same as the first example, the range will be y of y equal to real numbers. And the vertical asymptote will be x is equal to 1 half, which came from the domain x is greater than 1 half. Letter C, another example. Y is equal to log x by the base of 2. To find the domain, we should go to the procedure. So x will be added greater than 0, so it will be automatically, the domain will be x of x greater than 0. And to find the range, it will be the same as the first and second example, which is y of y equal real number. And the vertical asymptote will be x is equal to 0, which came from the domain x is greater than 0. Another example.
Y equal log x minus 1 by the base of 3 minus 3.
So let's find the domain. Finding the domain will be the same procedure as an example before. X minus 1 is greater than 0. So negative 1 will be transferred to the right side and it will be x is greater than 1. So the domain will be x of x is greater than 1. And the range will always be y of y equal to real number. Vertical asymptote will be x is equal to 1, which came from the domain x is greater than 1. Let's hear the last example.
Y equal to log x plus 4 by the base of 1/3.
To find the domain, x plus 4 is greater than 0. So, positive 4 will be transferred to the right side and it will become x is greater than negative 4. So, the domain will be x of x is greater than negative 4. So, therefore, the same as the procedure, range will be y of y equal to real number. And the vertical asymptote will be x is equals to negative 4, which came from the domain x is greater than negative 4. So we're done finding the domain, the range, and the vertical asymptote. Let's hear from finding the x-intercept and zeros of this following logarithmic function. So first example is
y equal log x minus 3 by the base of 3.
So we're going to find the x-intercept. In this situation, let ry is equal to 0. So it will be 0 is equal to log x minus 3 by the base of 3. Transfer the base 3 by the power of 0, so it's equals to x minus 3.
Any number powered by 0 became 1, so the equation is 1 equals x minus 3. So negative 3 plus positive 1 is equal to x equals 4. So the x-intercept will be 4 and 0. So the 0 will be the x-intercept equals 4, so over is x equals 4.
Second example, y equal log of 3x minus 6 base of 3 negative 2.
So let's find x-intercepts. Y equals log 3x minus 6 to the base 3. 0 equals log 3x minus 6 to the base of 3 and negative 2. Transfer negative 2, so it will become positive 2 equals log 3x minus 6 to the base 3. Let base be transferred, so therefore 3 to the power of 2 equals 3x minus 6. Multiply the 3 to the power of 2, so 9 equals 3x minus 6, and the final will be x equals 5.
Therefore, the 0 is x equal to 5.
So, the x-intercepts will be 5 and 0.
Third example, y equal log x minus 1 to the base of 5.
So let's find x-intercepts. Y equals log x minus 1 to the base of 5. Let y equal to 0. 0 equals log x minus 1 to the base of 5. 5 to the power of 0 equals x minus 1. Any number with raise of 0, it will be became to 1. So 1 plus 1 equals x. So 2 equals x. So transfer the x. So x equals to 2.
So our zeros is x to equal to 2. And our x-intercepts is 2 to 0. Fourth example, y equal log x plus 3 to the base of 2. Find x-intercepts.
Y equals log x plus 3 to the base of 2. Let y equal to 0. So 0 equals log x plus 3 to the base of 2. So 2 to the power of 0 equals x plus 3. So like what I said, any number with raise of 0, it will be became to 1. So 1 equals x plus 3. And 1 minus 3 equals x. 1 minus 3 equals negative 2 equals x. So x equals negative 2.
So our zeros is x equal to negative 2 and our x-intercepts is equal to negative 2, 0.